All right, let's do some factoring and some solving of equations. I'm going to show you all of these. Oh, I got a bug in here. There we go. I'm going to show you all of these, and then they are also on the slides that follow to step you through them as well, because they take a little time. So if I'm going to factor something to find the solution, the ideal thing to do is to move the 20 over. So I get 2r squared plus 3r minus 20 equals 0. Now, I'm going to try and factor that. If I couldn't factor it, I would use the quadratic formula, which we will talk about later in the slide deck, quite a bit later actually. How do I do something when there's a number in front? Well, I do something called decomposition. See, when we did these before, I'll get out my red, we were looking for something that multiplied to negative 20 and added to positive 3. But that's when there was no coefficient in front of the squared term. See this r squared term here? So now that there is, we're actually looking for something that multiplies to negative 40, because that's what 2 times negative 20 is negative 40. Right? And coincidentally, last slide we also had negative 40. But here we're looking for it to add to 3. Okay? So what multiplies to negative 40 and adds to 3? And if you remember the last slide, if you looked at it, 1 and 40, 2 and 20, 4 and 10, 5 and 8, those are our multiples to get us to 40. One of them has to be negative in each group. I need a negative and a positive because I'm multiplying to get to negative 40. So when I multiply these, I need something negative and something positive. So you start to think through it. Which of these differ by 3? Well, if I had a negative 5 and a positive 8, negative 5 plus 8 is positive 3. So negative 5 and positive 8 are going to be my numbers. Now, when we did it before, we were able to go straight to 2 brackets, put these numbers in. It was really nice on the last slide. Unfortunately, it doesn't work that way when you have a number in front. You have to do decomposition. So where I'm using these is here, 2r squared. I'm going to use these to replace the 3. So I'm going to go negative 5r plus 8r minus 20 equals 0. And if you're like, well, hold on, what did you just do? Well, I found these numbers, and it's a step-by-step process. I found these numbers. So instead of 3r, I actually did this, minus 5r plus 8r. And you're like, well, why'd you do that? Well, first of all, I want you to agree that minus 5r and positive 8r is the same as 3r, right? And you're like, okay, yeah, it is, right? But you went backwards. Instead of simplifying it, you spread it apart. But here's why. I'm going to now break this and do group factoring. I'm going to break it in half, and I can factor groups. Right? Here's how it's done. I look at just the first 2. I say, what's common? What's common to these 2 factors? And what I discover is the only thing that's common is an r. Right? So if I factor out a common factor of an r, well, what's left? That is an ugly r. It's bothering me. Sorry. I'll do that again. I'll factor out an r. What's left? Well, 2r squared divided by r is 2r. And minus 5r divided by r is minus 5. And hopefully you'd agree that r times 2r is 2r squared and r times, so we can factor that out. Okay? We're going to do the same thing on the other side. We're going to keep the sign right there, the next sign. And we're going to say what factors out of 8r and minus 20. 8 won't go, 4 will go, right? 4. So I can take 4 out. 8r divided by 4 is 2r. And minus 20 divided by 4, remember it's a plus 4, is minus 5 equals 0. Okay? And why we did that, why did we pick these 2 numbers and break it apart, is because when we do this group factoring, because we pick numbers that make sense, the brackets are the same, right? So now we get that common factoring, that awkward look from last week, or actually 2 weeks ago, right? Where we actually just have 2 terms, right? We just have this term here and this term here. And when we factor it, we're going to take a 2r minus 5 out of both terms. If I take 2r minus 5 out of this, I'm just left with an r. And if I take 2r minus 5 out of this, I'm just left with a plus 4 equals 0. Okay? And if factoring is not something that you love, make sure you go back and look at these a couple of times to see how it works. But this is decomposition. Now we've broken it down. Then we can use that zero product rule and say, all right, well, if this bracket and this bracket equals 0, then it's only true if that bracket equals 0 or this bracket equals 0, right? So 2r would equal 5 and r would equal 5 over 2, or, remember it's an or, r would equal negative 4, okay? And that's our two possible answers, 5 over 2 and negative 4, right? So we could say our solution set here, where am I? Got too many markers in my hand. We could say our solution set is negative 4 and 5 over 2. I always like to put the smaller number first and the negative is smaller. Okay. I'm going to go to the next one. If you need a minute with that one, just hit pause. Right? But I'm going to go to the next one. It's similar but different. Right? Because I need these to equal 0 to work. So I got 6d squared plus 42d equals 0. See, I brought the negative 42d over to the left, and I have to switch the sign from a negative to positive. Now this one's easier to factor because there's only two terms, so all I'm doing is a common factor, and the common factor is 6d. So if I take 6d out of 6d squared, I'm left with d. If I 42d divided by 6d, I'm left with plus 7 equals 0. Okay? So we got there a heck of a lot quicker and a heck of a lot easier, but we still then have the same scenario here where, I mean, we don't have to put this in brackets because it's a common factor and no plus signs, but you could consider it as a bracket, right, the same way. And we'd say 6d, get this out of the way here, 6d equals 0, or d plus 7 equals 0. Well, if 6d equals 0, we divide both sides by 6, 0 divided by 6, d is 0, or d is negative 7. Whoops. Need an equal sign. Okay, d equals negative 7, right? And we can do our solution, I can put it down here because I have space, is negative 7 and 0, right? And what you can do, you say, well, I don't know if it's true. If you want to, take negative 4, for example, sub negative 4 in here, and see what you end up with. Well, negative 4 squared is 16. 16 times 2 is 32. 3 times negative 4 is minus 12. 32 minus 12 is 20. So it does work, right? We can, don't pick 0 because it's easy to pick negative 7. Negative 7 squared is 49. 49 times 6 is a big number. 49 times 6, 50 times 6 is 300. 294, right? Negative 42 times negative 7 is also 294, okay? So it works that this side equals that side, and that's how we know there's a solution, okay? All right, I'll take a second, I'll step out, let you have a quick look. And pause it if you need to. We'll move on to the next couple here. All right, let's look at the next ones. Whoa, that was so long my computer almost shut off here on me here. All right, see, k squared equals negative 12 bracket k plus 3. This is ck squared equals, I'm having trouble here. The negative 12 is outside of the brackets, and then k plus 3, negative 12 and k plus 3. Okay, we'll look at that one. And then d, x squared plus 12x plus 27, x squared plus 12x plus 27 equals 0. Okay, we'll look at that one. And then can we look at the last one here? Sure we can. Z minus 8, that one, you know what? Let's look at that one, it's going to take a bit. Okay. Here we go, trim blue. Well, if I do this, k squared equals, I got to multiply that out, minus 12k minus 36, okay? That's not so bad. I got to move everything to the left. Remember, I need to make it equal to 0. So I have k squared plus 12k plus 36, right? I got to change the signs from negative to positive, equals 0. Well, now, these look very different, but now they look very similar, don't they? Very, very similar. So here we go. I need 2 brackets, because there's nothing in front of the k squared, so I can do it the quick way. I can put k in front of the first brackets. I need something that multiplies to 36, adds to 12. Okay. Remember, so we're looking for something that multiplies to 36 and adds to 12. Well, 1 times 36, 2 times 18? No. 3 times 12? No. 4 times 9? 6 times 6. 6 times 6? 6 plus 6. Alright, so here we go. Let's use the right color. 6 and 6. When I multiply those, I get 36. When I add them, I get 12. So we actually only have one solution, because we say k plus 6 equals 0, or k plus 6 equals 0, but they're the same, so that's repetitive. So really, k equals negative 6. So the only solution we have is negative 6, just one number. And that's okay. There's only actually one number that will work for k to make that work. All right. This one's very similar. In fact, instead of k squared and 12k, it's x squared and 12x. But this one's plus 36. This one's plus 27. That's the only difference. So when I go to factor it, I'm going to go straight to 2 brackets again. X equals 0, right? Now, I'm looking for something that multiplies to 27, but adds to 12. Okay, and again, think about it. 1 and 27, 2, no, 3 and 9. That's the only options. So it better be one of those. What if it's not? If it's not one of them, it doesn't factor, and therefore you can't use this factoring technique to solve the equation. But we have some other techniques that you'll be able to use, so not to worry. We'll see that in these slides as well. But here it does. 3 times 9 is 27. 3 plus 9 is 12. So where's my black? Looks like we have a plus 3 and a plus 9. Okay. So x plus 3 equals 0, or x plus 9 equals 0. That means x equals negative 3, because negative 3 plus 3 is 0. Or x equals negative 9, because negative 9 plus 9. And you can check it, right? Pick negative 3. Negative 3 squared. Negative 3 squared is 9. Negative 3 times 12 is negative 36, and that's a 27. 9 minus 36 is negative 27, plus 27 is 0, and it works, right? And the only thing you have left to do is show that your solution set is negative 9 and negative 3. If I put negative 3, negative 9, it would still be correct. I like to go from the smallest integer and move up. Okay. Again, I'll step away for a second, and then we'll look at the last one. All right, here we go. Okay, the last one here is, oh, gotta get to the round. Z minus 8, Z minus 4 equals 5. So we got Z minus 8, Z minus 4 equals 5. I like to put little ticks. Excuse me. I like to put little ticks on my Z so we know they're not 2's. Okay. Z minus 8, Z minus 4 equals 5. Here we go. So it would be really nice to say, hey, well then Z minus 8 equals 0 and Z minus 4 equals 0, but that would be wrong because this does not equal 0, this equals 5. And the rule only works if this equals 0, that zero product rule, right? We have many, many options of two numbers that could multiply to give us 5. 1 times 5, a half times 10, a quarter times 20, you know, the square root of something times the square root of something. We have tons of options. So here's what we need to do. We actually, unfortunately, need to multiply this out. So this is Z squared minus 4Z minus 8Z plus 32 equals 5. Okay? And then we need to collect like terms. That's minus 12Z plus 32 equals 5. We bring the 5 over because we need this side equaling 0. Z squared minus 12Z. Bring that over. Subtract it, plus 32 minus 5, I'll do all the steps here, Z squared minus 12Z plus 32 minus 5 is plus 27 equals 0. Oh, very, very similar to number 4, okay? Very, very similar. And this is, I want to show you how things tie in. You didn't think that was going to be very, very similar, did you? Not at all, but it is very similar when we get to this point, right? So it's not identical though. Okay, because if you looked at the last example, we know Z goes in the front. In this case, it's slightly different because we're looking for two numbers that multiply to 27, but add to negative 12, right? And when we did example D, we said, all right, 1 times 27 and 3 times 9 is the only things that multiply to 27. Neither one of them add up to negative 12, but there are some other options. Negative 1 times negative 27 is also positive 27, and negative 3 times negative 9 is also positive 27 when I multiply it. And you'll notice when you add them, negative 3 and negative 9 do add up to negative 12. So I can use negative 3 and negative 9. Okay. And you may have been a little bit surprised that this worked out to almost the same answer in D, except a negative sign here. And then we have Z minus 3 equals 0, or Z minus 9 equals 0. So we know that Z equals 3, or Z equals 9, right? And we don't have room for our solution set over there, so we can put it here, 3 and 9. Okay? And that's how we do solving by factoring. The next slides will lay it out for a few slides, all of these details, but I want you to also see it in a video, and we'll see a little later in the PowerPoint presentation.